Hi everyone, this is Thiagarajan, retired Deputy Chief Engineer from Indian Railways. So in this video, I am going to discuss something about the layout designs for railway station yard in Indian Railways. It's a part 1 video. Here I am going to touch upon this introduction to the layout calculation and the how to do the proper design of layout. In case of improper design, what will be the consequences? Okay. And as far as this design is concerned, we are going to do mathematically, and for that, we need to know something about trigonometry also. So I'm going to do some fundamental trigonometry portion also. I'm going to cover. Okay. This will go into the subject. Without further ado,
so first let us start. What is the layout? The definition of the layout. So the layout is nothing, the way in which the parts of something are laid on a plane, or ground, or any plane. So maybe knowing about your layout, like plot layout, road layout, pipeline layout, something like that. But in our scenario, it is about the track layout. So you must be knowing the station yard. So how many lines are there? You can see, you can visualize. So the entire network, the geometry of that, how it is fixed on the ground. So we cannot lay that just like that arbitrarily. We must have some rational approach. For that we need some procedures and rules and regulations, norms, and we have already schedule of dimensions, restrictions, limitations, everything is there. So the layout designs, in which context it is needed. So maybe knowing overall construction. Suppose if you want to form a new line from between X and Y station, you are forming a new line. So in between we will come across some towns and cities, and where we need to provide station. So according to traffic density and techno-economic survey, that will be decided, and number of lines will be decided, and the yard layout will be designed. That time also it is very essential. Unless we have we know something about layout designs, so it is very difficult. And the remodeling of existing yard. Suppose if you have the existing yard, it is to be remodeled. For example, we have a single line section. Now we go for a double line section. So what will that necessarily this station has to be modified. Station yard has to be modified, because there we have double line, up line, down line. So up line trains has to be dealt in some line, some portion, and down line train has to be dealt in different portions. So definitely there will be some additional lines involvement. Some connection will be involved for up line and down line separately. Maybe some common loop will be there of the emergency crossover, something like that. So that time also remodeling is very essential. We have to do it. Of course, the loop extension work, the senior, section engineers who are in maintenance, PO maintenance, sometimes they will come on loop extension work. Maybe existing loop line, here will have the capacity of only some 14 vehicles, 17 capacity. So the loop line has to be extended to 24 vehicle capacity, necessarily has to be modified. The loop line has to be modified. That means the shifting of points and crossing will involve. And so that time also we need some knowledge about this layout calculation. And any minor modification, suppose the existing layout is not functioning well, that means maybe defective, always there is some problem is there. So that case what we will do, we will some measure, some do all survey and all, and finally we will decide, no, the points has to be shifted some slightly. That time also we need we have to apply some mind and do it. So the background of the layout design, you will be able to do all those things. So this is a typical station yard you see. See here you see how many number of lines. So many lines are there. Parallel and non-parallel lines and all there. They are connected together, forming a major network and complex in nature. So this geometry has to be fixed on the ground. So this kind of geometry you want to fix. So that time also we need a design, the proper design. With the help of some rules and regulations, some formula, then we have to do it. That we are going to discuss now. Again, this is a station layout. You see here, this is a single line. Let us take this is a line. You have to see how many parallel lines are there. How many parallel lines? Sometimes we have the non-parallel lines, and some one line is taking off from the main line. So this is yard. This is to be designed. So normally, if any one line is there and branching it take place, no, with one point somewhere is called normally used to say it is a connection, simply connection. Suppose in between two tracks we are introducing a connection, it is called crossover. That means the connection it is having only one point sun crossing involved. Normally, for doing this connection, wherever change of direction take place, what we do? We used to introduce a device called point sun crossing. That already we have discussed. You know pretty well about the point sun crossing. This is the point sun. With the help of point sun crossing, we are doing such connections. With only one connection, we are doing this means connecting two lines is called simply connection. In between two parallel tracks, we are introducing a connection with the 2 points on two turn-on is called crossovers. Crossovers. Okay. Of course, you know this is scissor crossover because the same portion, two line crossing each other. This is called scissor crossover. In between, we have diamond crossing. So this is the arrangement. And you see here, just like a ladder. So one line, lot of lines are branching. It's called a ladder track. It is just marshalling or sorting or used to do like that. So, like that there are so many type of connections are there. These connections are to be done how? That, okay, we have to discuss. As I told you, it is a loop extension wire. See, this is the main loop line. We want to extend it. So the point to be shifted. When you are shifting the points, how it is to be, where it is to be located, and how the connection, this connection curvature has to be introduced. You have to design. Okay, why the layout calculations? Again, why? In which situation we know. We already discussed. Why the layout calculation is needed? Many of you may be knowing who are in the field. Layout is not properly done. Fixed. We will have a lot of problems. There will, the smooth negotiation will not be there. There will be jerk, jolting, everything will be experienced, passenger will experience. So for smooth negotiation over the connection to ensure safe comfort to the passengers. And many places you can see the station yard, when main line to loop line it is negotiating, the vehicle will negotiate with strained movement will be there. There will be noise also will produce. And there will be more wear and tear to the rail components. Sometimes there is jolting also. So all these things because of the defective layout. So that can be avoided if you properly designing it. And to avoid unsafe conditions. See, ultimately if it is defect is more extremely, it will result to some derailment, something like that. That can be avoided if you are doing proper layout design. And minimize wear and tear of the track fittings and defective layouts leads to frequent. That means you may be knowing. Suppose if we take a major, some wayside station, there will be run-through trains. If the layout is not proper, suppose let us take top point is not properly laid, what will happen? There will be some misalignment. Even though we do some machine packing, every time we are correcting the alignment, because of the improper layout, frequently this running out. That means this alignment this position will go to the original alignment. There will be always misalignment. If it is so, what will happen when the trains are running at sectional speed, and running over the point, there will be a lot of jerk, jolting, everything will be there, knocking will be there. So ultimately there will be setting up of vibrations. Once the vibrations set, what will happen? You see, the packing will get loose, the fittings will have more wear and tear, it will become loose, and often our keyman has to be refixed, and we have to replace the fittings again, formation of grooves in the sleepers, and crushing of rubber pad, crushing of liners, all will take place. Frequent maintenance will take place. That should be done. So unnecessary expense, it incur additional expenditure also. To avoid this wear and tear to the components and frequent attention, the proper design of a layout is must. That is to be taken care. The proper calculation, proper design of the layout is must, okay, essential. For example, let us take simply crossover. For example, there are two lines or parallels are there. They are to be connected with the crossover. What do? We have to insert a points on crossing and insert a point 1 and another track also. We want to do it so. It's must. The heel of cross should not have the kink. The heels of crossing, here. Suppose we want to introduce a crossover between two tracks. We need 2 points on turnout has to be inserted. One in one track, other one is another track. And it is to be connected. It is to be connected in such a way, we should not have any kink at the heels of crossing. Any kink. In order to not to get any kink, what is to be done? What length we need? That overall length we have to find out. So the overall length we have to calculate in order to get 0 kink at the heels of crossing. How to find out the overall length? That's must. Suppose the overall length should be exact. So for example, suppose in order to get good smooth negotiation, we cannot keep the other points on crossing far away. The relative distance with respect to, suppose this location of the SRJ1 is known, we are fixing this turnout. The other point SRJ location you must find out with respect to SRJ1. For that we need overall length. Suppose at the same time we should not think if we are fixing the turnout far away we will be getting the smooth connection. It is not so. For example, see here. This is one point on crossing, turnout you are fixed, other point somewhere you are fixing it. In that case also we will be having the kink. So we should not have the location of the other points on crossing with respect to the first one. Should not be far off. The same should not be very close. It should be exact. So again in that case we have the kink. It should not be there. Again if you do this way also it will be a problem. If you are so close, between the distance between 2 points on crossing so close, there also that time also we have the kink. So you have to calculate the exact distance, so in such a way to get no kink at the heel of crossing. So how to be found out, that we have to design.
So as far as the layout calculations are concerned, we have different methods, and particularly or at present we use centerline method. So earlier you would have studied about some Coles layout, Coles method. Now the present method of centerline, using centerline, it has been simplified.
So following this procedure also some software applications are available. Some medicine also has some software is there. Egbote somebody made some software for finding out the overall length, all measurements, whatever we need for fixing the geometry, layout geometry. Even my own application also available. It's in my website. V.Thiagarajan.com it is there. I made some models for this software main applications. And outer rail method is also manual calculation, but it is adopted only in the case of curved lines. Suppose 2 curved lines are there. We want to introduce a crossover between 2 curved lines. If we want to introduce a connection between 2 curved lines, and that time and that situation, we are using the outer rail method. That we will see. That is very complicated. That we will see later. So this is about the method, manual way of designing our layout calculations, doing layout calculations. Mathematically calculated, it is completely involved in trigonometry. If you know trigonometry, it will be very easier. And graphical method. Graphical method is computer subject, AutoCAD. So using the AutoCAD we can do it. Centerline method, as I told you, it is only centerline, not centerline. We will go in detail later. And outer rail method, it is only for curved parallel tracks, curved non-parallel tracks. And graphical method, it is using AutoCAD with the other software. But even though we do AutoCAD, using AutoCAD, one cannot do. Simply knowing the AutoCAD cannot do the designs. We should have the basic knowledge of the layout designs. So you should know what is turnout, what is the SRJ, the overall length, and what is connecting curve, what is the tangent point, what is tangent. Okay, everything you must know. Unless we know that, and it is very difficult. So simply knowing the AutoCAD you cannot do it. There also you should know the basic knowledge of the layout designs. Okay. Of course, this is a points and crossing. Already you may be knowing, discussed also. This is something about PS sleeper for various turnout, 1 in 1 in 12, 1 in 16, 1 in 20. What is the switch entry angle that is available? And some radius. Mainly radius you must know, because radius is very important for layout calculations. This is radius. For different turnout, this is the radius of turnout. 1 in now 232 is coming, 441 is for 1 in 12, and 116 784, and 128 something, 12,283 meters for 1 in 20. So coming to the crossing angle, this is some trigonometry, you know. If you want to know what is the crossing angle first. What is the crossing angle? The crossing angle is, the amount of deviation takes place. Suppose for 8.5 unit, 1 unit diversion is taking place. It's called 1 unit of turnout. In the turnout, we have the crossing. There you can see wing rail, nose rail will be there. There will be piece will be there. That angle will be equal to F. If it is 1 unit of, means for 8.5 unit, 1 unit deviation takes place, is called the 1 unit of. If it is for 12 units traveling, 1 unit deviation takes place, 1 in 12, and so on, 16, 20, 20. The crossing angle is nothing but, you see, need not by heart it, 6 degree 42 for 1 in 12. It is only the formula, tan F. You know, tan F means what is opposite side to adjacent side. Tan F equal to 1 by 8.5. Tan F equal to 1.85. F is equal to tan inverse of 1. If you put the calculator, you will get the value. This is the crossing angle. Similarly, 1 in 12, tan F equal to 1 by 12. So F is equal to tan inverse of 1 by 12. F, this is the value. So similarly, this is the crossing angle. That means according to the amount of deviation takes place. So 1 in 12 means more deviation will take place. 1 in 12 slightly lesser. 1 in 16 further. 1 in 20 flatter, like that. Okay, this is crossing angle. Okay, we will come to the crossover. Just for sample, just to make in how it is calculated. Let us take a crossover. There are two parallel lines are there. We have to introduce a crossover. How to calculate the overall length? The overall length already discussed. It is must. It is for fixing the relative position of the two turnout. It is must. How to find out the overall length? You see, there are so many lines. This track, again curvature. So many lines are there. It is confused. So with that, if you see, it's very difficult to find out. So for simplicity, what we are doing now, in our recently, we started adopting the central line method. We forget the all main lines and all, gauge rail, track, gauge rail, and only we are considering the central line of the main line and turnout line. With the help of that, we are going to, nowadays we are doing it. See, for example, if you see, this is central line of the track, road 1, central line of the road 2. This is central line of the crossover. So this is called the point of intersection. That means where the turnout line intersects with the main line is called point of intersection. Similarly, here also point of intersection. The amount of diversion equal to F only. The angle included angle is equal to F. But this is not a crossing actually. This is a point of intersection. Our nose of cross is somewhere here. So the angle will be F, because this line is parallel to this line is parallel to this line. So automatically this angle will be equal to this angle. This is point, this is it. So this is central line representation actually. Here in that case, what we do, we are removing all the gauge lines. Now it is very simple. So only we are having the two central line of the two tracks and we have the crossover lines and forming some triangle. So with now the sketch is very simple, and from there you will be able to find out the required distances. Here again I am telling you, this is center line of the main line and turnout line. This represents the points on crossing. Whatever I made in red represents the points on crossing. So we are removing the gauge line, only we are taking the center lines of the main and turnout. So for any points on crossing, this value is same, constant. Suppose if you take 1 to 12 points on crossing, the value of A and B are same. Okay, this is readily available. Because points on crossing, your dimension and all constant, Suppose 1 to 12 means, overall length of the turnout, 1 to 12 means, already. So here we have a table of dimension where you can find the value of the A and value of the B. Each and every points on crossing. So the A is constant, A, B and all constant. But here in this case, we want to find out the overall length. We want to know X and A. A is constant, it is readily available. Only this left out is X. The overall length, the only left out is X to be found out. X can be found out using this triangle. You take this triangle here, we want to find out the X. What do you need? For any this thing, if you triangle, if you know the angle, if you know one side, you will be able to find out the other side. Here the distance between the two tracks D. That means the opposite side is known. The opposite side is, the value is, this is D. So we have to find out the X. So X equal to D by X. Opposite by adjacent side equal to tan F. So X equal to D by tan F, X equal to D cot F. So once we know the value of X, we will be able to find out the overall length. That is equal to X plus 2A. X, A plus A. X plus 2A. So simply you can find out. Here, suppose for assuming that this track distance is 5 meter. 5 meter to take. We are introducing the turnout 1 in 12 on both the tracks. 1 in 12. What is the overall length? Without calculator you can find out. Here D is 5 meters. The points on crossing we are using in road 1 is 1 in 12 and the road 2 also 1 in 12. What is the value of X? A I am telling you can take 12 meter. You find out only X. A already available. A let us assume some 16 meter. Here 16 meter is 16 meter. 32 meter 2A. X value find out. What is the X value? Cot F is equal to simply number. Cot F equal to simply number of the points on crossing. If you use 1 in 12 on both the tracks, what is you have to take the number of points on crossing. What is the number of the points on crossing? 12. 1 in 12. The 12 you take. 12 into D will give you the X distance. So 12 into 5, 60 meters. So 60 plus 2A, let us assume that 16 meter A distance is 32 plus 60, 92 meters overall length. It is 92 meters. Why I am telling you D cot of 1 by tan F equal to the angle of crossing. Suppose I already told this is 12 means this is 12 unit to 1 unit diversion. That means 1 by tan F. But cot F equal to 12 by 1. That is 12. So 12 into distance, if you take 5, 12 into 5, 60 meter. Plus 16 meter. Here 16 meter, 32. So 92 meters overall length. So this way we can calculate. So having this value, we can interpose the distance. After fixing the one turnout with respect to the reference to this SRJ, we can locate the SRJ of the other points on crossing. We can insert the points on crossing. Ultimately, if we give the connection, this will be perfect. There won't be any kink. This is a way of doing the design as far as crossover is concerned. Since crossover is simple, that is why I taken the example here. So this is central interpretation of a turnout. See here, if you take a points on crossing, this is main line, this is turnout line. This is central of the turnout, main line, turnout, as already discussed. This is point of intersection. This SRJ to point of intersection is A we are denoting. Intersection to heel of crossing B we are denoting. Similarly other side also. M and K of course intersection to this nose of crossing M, beyond that it is K. This M and K normally we will be needing only in the carried tracks and all. That we will see, that is a little complicated. Main thing we need A and B is very important. A and B is very important. So angle, of course, this is already discussed. This angle will be in this angle. This angle will be. This is simply removing all gauge lines. If we take this, this will be a black box. That is, it represents the center line of the turnout. A, B, B. This is your crossing angle. This is your point of intersection SRJ. Okay. Something about terrain curve, just for explanation. When any vehicle coming from the main line, when the train is turning out, it's called turnout. After that, when it is turning in with reference to main track, turning in is called turning curve or connecting curve. Okay. This is something about the dimensions. Already discussed, what is the value of A, B and all. This is a table dimension available, readily available. Simply we can make use of these dimensions. We can fit in the formula, plug it in the formula and find out the required values. So for various rails section and type of crossing, this is the value available, A and B. Here you can see B and B modified. B is this is one, this A, B and all, it is for A and B. B modified means what we need nowadays in case of PSC turnout, PSC turnout, we always need some straight portion beyond the points and crossing. Beyond the points and crossing we need. So the common sleepers will come into play. So for the purpose of calculation, even though your points and crossing ending at heel of crossing, we are assuming that it is further extended, the side portion further extended for some distance. So that is why the V value will become slightly more. In normal one sleeper and all, previously this thing it is only the B value. Now we want to have common sleepers extra beyond the heel of crossing for some distance. That track should be straight for some distance. So that is why the extra length is added now. B value is added. Here you see 1 unit of PS layout 3.3 meter is added further. From beyond the heel of crossing 3.3 meter added straight. There we will have the common sleepers. 1 in 12 5.5 meter extra further extended. 1 in 69 meter and 1 in 20 9.15. So because of common sleepers section these were for the calculation purpose. So our B value getting little extended so that we want to maintain the straightness up to that point. That means this length is actually here heel of crossing, but further we are extending straight portion. Further we are extending straight portion. Let's see about the parameter of the triangle. This is a right angle triangle. Sine rule we must know for calculation purpose. Suppose you want to relate opposite side, hypotenuse and angle. Okay. This is your sine rule. Sine theta equal to opposite by adjacent, hypotenuse, ABC. So if you want to, with respect to this thing, if any one side, two values we know, other value we can find out. Okay. A we want to know, if you know C into sine theta will get A. And C equal to A by sine theta. So this rule, sine rule. Then this is a cos rule. Cos rule is relating hypotenuse, then angle and adjacent side. So cos theta is equal to adjacent side by hypotenuse. So cos theta is equal to B by C. Okay. Anyway, if you want to find out the B, knowing C and angle, we can find out B is equal to C cot theta and C equal to B by C theta. If C is not known and B is known. So this is our cos rule. This is right angle triangle. This also. So this is here tan theta equal to opposite by adjacent side. Tan theta equal to opposite by adjacent side. Suppose theta we know Sorry, if we don't know the opposite side, we can find out relating adjacent side and theta. So tan theta equal to A by B. Cot theta equal to 1 by tan theta. So that's what I told. So 1 by 12 means tan theta. 1 by 12 points. If you take a point class 1 in 12, 1 by 2 equal to tan theta. So cot theta means simply 12. So cot of is equal to 12. So 12 liter distance will have the distance of x. That's what I told. So Pythagoras theorem is, suppose only all three sides we know, we don't know the angle, using this, this relation we can find out the other side. C squared equal to A squared plus B squared, or C equal to root of A squared plus B squared. This is our tan rule. Another parameters of a triangle. See here, gentlemen, this is a triangle. Of course, sometimes it may come across relating all sides and angle. A by sin A equal to B by sin C. If you suppose you know A you don't know, sin A you know, B you know, sin B you know, using this relation you can find out the E like that. This is coming. Sometime this is your line. This is coming. Our calculation. This portion is not always coming. This is to come. This will come. So this is one line. One line intersecting here. Another line here. So there will be included angle. This included angle will be equal to this angle minus this angle equal to this angle. Okay. This is not to calculation. Because sum of internal angle will be equal to 180 degree. Sum of internal angle 180 degree. This is theta. This is 180 minus theta. This portion. So automatically we'll find out this value. This is this relation. 180 minus theta minus f equal to f minus theta. This is some application. This is this thing you must know. Okay. This is the curve parameters. Curve parameters actually this is to be known not only for layer calculation, even the laying of curve, setting out of curve and all. You must know the this one, notations and all, and the parameters. Importantly, what is tangent you must know. Suppose two line intersecting, or the line is taking a change of direction here. So this will be a deflected angle. This is one line is coming, going, and it is to be take a turn like this. Or the two line are intersecting here. This is called deflection angle. This is called deflection angle. So in between the two lines, we want to introduce a curve because we want to, our vehicle has to take a change of direction. Change of direction cannot take suddenly. Our vehicle cannot negotiate 90 degree bend like a road vehicle. But wherever there is a change of direction takes place, we have to introduce a curve. If it is a main curve, it will be major curve. In case turnout, we are having some simple small curve used to provide. So, due to change of direction, you introduce a curvature here. You are introducing circular, let us assume. So, for that we need this certain parameter you must know. What is tangent? How to calculate? What is the relation between the radius and the tangent? You must know. For any calculation, the tangent is very important. Tangent calculation. T equal to, here I put T equal to r tan theta by 2. Here you can see this is your straight line, one line, other line here. This is your tangent point 1 where our curvatures take a start, and it is ending at TP2. This is a tangent point. This length is called tangent. That means the distance between the tangent point 1 and the point of intersection point is T. Like the intersection point 2, TP2 is the tangent. This is the angle of deflection angle. This is the radius of the curve we are introducing. So T equal to r tan theta by 2. How? The T value you have to find out. Always T is important value for calculations. We are taking this triangle. Tan theta by 2 equal to T by R. So T equal to R theta by 2. How we are getting the theta by 2? Suppose this is the deflection angle, this is known. We are how much angle of deviation takes we know. This angle equal to always the angle separated center. Okay. This angle will be deflection angle equal to angle subtended center. This is the formula. If you can calculate also easily, because this is theta. This is 180 minus theta by 180 minus delta. This is 180 minus delta. Since it is a bisector, this is 180 minus delta divided by 2. That means this portion, this angle will be equal to 90 minus delta. Once this is 90 minus delta, this 90 is there. Total sum of angle equal to 180. So 180 minus 90. Okay, 180 minus 90 minus 90 minus delta by equal to delta by 2. This is delta. This is delta by 2. Total angle will be delta. So always in that curve parameter, the angle, the different angle subtended at center is equal to deflected angle, deflection angle. Okay. So knowing this, taking this triangle, knowing this angle, we will be able to find out the relation between the T and R. Suppose you want to introduce a curvature of some 400 meter radius, what will be the tangent? You can find out using the relation theta equal to r tan theta by 2. Okay. This is something about the curve parameters. So tangential connection. So wherever there is a change of direction takes place, we are introducing the curve. How to be introduced? Is it correct? Always that curve should be connected such a way, tangentially. This is wrong, because this is wrong. This is also wrong. Should be like this. That means should be tangential. That means the angle between the tangent means this is straight line, and the radius drawn here connecting the center should be equal to 90 degree. Okay. If you do like this, somewhere the tangent will be coming here, the angle will not be 90, it will be more than 90 degree. Wrong. If it is connected like this, the tangent will be like this, the angle will be lesser than the 90 degree. Is wrong. So always should be tangential, and then only we'll have the smooth connection. There won't be any kink. Otherwise, at the tangent point, at the entry point, there will be sudden kink jerk. So always that connection of the curve should be tangential with respect to your straight line. This is tangent.
Okay, let's see the minimum radius of turnout and turning curves now. Okay. As per IRPWM para 408, there is a provision for what type of points and crossing we must provide, and what is the minimum radius of the curve we must ensure in the connecting curve portion, and all everything has been given. We are supposed to follow that. Okay. Actually, for passenger running lines, we must provide only 1 in 12 curved switches. Okay, that is preferable. Passenger running lines is what? The lines which are dealt with the passenger trains. Okay. So those lines preferably we must go for 1 in 12. But in case of any contraflexure, when the point is on a curve, forms a contraflexure, that turnout side takes off from the main line, away from the main line, it will form contraflexure. And that situation we can provide 1 in 8 now. That too with the approval of principal chief engineer. Because normally, you are 1 in 12, it's a flat radius. The lead radius is equal to, that is 441 360 meter. But whereas the lead radius of the 1 in 8.5 is 232.26 meter. Okay, it's sharper. That's why preferably for the passenger running lines, we used to go for the flatter radius, that 1 in 12, that means 1 in 12 or flatter. Okay. And emergency crossover, normally, it will come into play in case of, multiple lines, double lines, and all used to provide 1 in. And when we are providing a 1 in of points and crossing on these running lines, okay, we must ensure that it should be only the trailing directions, not in the facing directions. Okay. Of course, snag detent, that you might have seen, all stations for fire station purpose we used to provide snag detent, and that location is preferable, and it is advisable to go for 1 in of symmetrical split, because normally 1 in of symmetrical split when you are providing, it is giving the advantage of 1 in 12, because when we are designing as a symmetrical splits, that 1 in of turnout radius will become equal to 1 in 12. So we are able to get the advantage of the 1 in 12 with a limited space. Okay. And also, even any escaped vehicle also, it will be taken away from the main line. Okay. so that we can ensure no infringement with the main line. Okay. Then in case of contraflexure, so when points are crossing, when it is on a curve and the turnout side takes off from the main line, forming a contraflexure, and that case also, there are instructions. Some you must go for only 1 in 12 flat. 1 in 12 always you must prefer 1 in 12 or flatter only in case of passenger running lines. And at the same time, the resultant because of the contraflexure, because of the curvature, the effect of the main line, and that resultant radius of turnout at any cost should not be sharper than 350 meters. But of course, when you are providing 1 in 12 or flatter, in case of contraflexure, and when you are providing on a curved line, always it will become further flatter only. So 441 will be more only. But if they are given the instruction that is 350 meter less than that should not be there. But it is in the case of 198 when you are providing, okay, we must ensure that the result radius should not be sharper than 290 meter, that is 6 degree. That with the approval of PC. So normally we should not go for a 1 on running line, but in case of any space constraint, we want to provide 1 points on crossing as a contraflexure. However, the resultant radius we must ensure should be flatter than 290 meter. That with the approval of PC only we must plan. And coming to the similar flexure, so when any points on crossing when is on a curve and the turnout side taking inside of the curve, it will form a similar flexure. In this case, the resultant radius should not be sharper than 350 meter. When but we can go up to 290 meter, but with the approval of principal chief engineer. Here, provision of 1 points on crossing on a similar flexure is not permitted, because see, when we are providing a points on crossing on a curve as a similar flexure, the turnout 1 radius is how much? That is 232.26 meter. That means 8 degree. Suppose when you are providing the points on crossing on a 2 degree curve, what will become? The resultant radius will become 8 degree plus 2 degree, 10 degree. So it will become sharper. So that is why we should not go for 1 points on crossing or similar flexure. But at the same time, we can go for 1 in 12 or flatter. But at the same, that also you must see, because of the similar flexure, further it becomes sharper when you are providing on the main line, curvature, curved line. At any cost, the result radius should not be sharper than 350 meters. Okay. For example, 440 meter radius of the 1 in 12. That means let us take 4 degree. This main line is some 2 degree. So what about the resultant radius? That will become 2 plus 4, 6 degree will come. Okay. But 6 degree normally, 350 meter means actually it is 5 degree. Okay. Up to 5 degree, it's okay. But it is further it is become sharper. It becomes 6 degree means then we have to go for the approval of principal chief engineer. Okay. But beyond that, we should not provide sharpness. We should not provide the resultant radius. Must ensure like that. Okay. Then minimum radius of the turning curve. So turning curve means what? That is connecting curve. Whenever we have main line and loop line, the turnout after turnout curve there will be turn-in curve. The turn-in curve, whenever we are designing, we must ensure that the radius of curvature should not be sharper than 350. Normally, so we should adopt whatever radius of turnout, same radius we have to adopt. 1 in 12 radius we have to adopt. 440 to 440 we can adopt. But however, because of some reason, some site situation, we want to provide that much radius. Okay. So we can go up to 350 meters. Should not be sharper than 350 meters. Okay. But at the same time, still the condition is some situation is not conducive for providing 350 meters radius. You must go up to 220 meter, but you must ensure the track structure completely as per the at par to the main line. Okay. So sleeper density and ballast cushion, everything must ensure. Okay. This is something about the turn-in curve. and what type of points and crossing you must provide the various situations. Okay, so while we are designing our layout, these things are to be taken to consideration. Okay, then a different type of track connection. So already we had been seeing our track network in a yard. We have so many parallel lines and non-parallel lines. They are connected together, and so there will be many situations, and those situations to be properly designed and connected, and geometry to be fixed on the ground. For that, proper data has to be arrived at based on our necessary calculation. But here, as far as we are concerned, here we are going to discuss only the mathematical calculations using some trigonometrical formula and all. But of course, this design can be done even in a graphical way also using AutoCAD. But knowing the basic things, applying those things in AutoCAD, graphically also we can draw, and from there we can take the necessary dimensions for fixing the geometry on the line. And also we have other special softwares available also. Okay, simply connecting, drawing, and we are fitting the curve. Automatically curve will be fitted. Necessary dimension will be okay. We can obtain it. But however, here we are going to discuss only mathematical how we can design and various parameters, dimensions. How can we get it? That we are going to see here. And as already discussed, we have different type of connections we have. See, for example, sometime one line will come from siding, so it will connect with the main line. Okay, but in this case, the siding line, it is just meeting the main line, forming an inclination of theta. When the inclination angle is equal to angle of crossing, suppose when we are providing 1 in 12 points on crossing on the main line, we want to connect with siding, the crossing angle equal to the angle of inclination. In this case, there won't be any connecting curve. Straight we can connect it. Okay, the center line of the line will be extended, meeting in the point. This is the point of intersection. From here we can mark, okay, the A distance, and that will be SRJ positions. When you are introducing points and crossing here, you can straight away connect it. There won't be any need of any connecting here. In the other situation, suppose siding line is coming here and the extension meeting at some point, the main line. But when you are measuring that inclination angle, that angle will be more than the angle of the crossing. Suppose when you are using only 12 points on crossing, so 4 degree something angle of crossing. This is around 6 degree. It is more than that. In this case, we cannot directly connect it, and necessarily there will be a connecting curve. This extension meeting one point, that point of intersection. But we got to form a curve here. So connecting curve we have to form. That curve we must provide. Normally the prescribed radius we must provide. Okay, and we are providing how for this thing. How to fix our the point. That means x distance from point of intersection to the point up to which we have to form curve. That point we have to locate it. So we must know x distance, y distance, or from SRJ and all. We must calculate the overall length. Okay, from SRJ we have to mark overall length. From here y distance we marking this one. After that the line will be taken straight. After that we have to introduce a curve in between that, like that. So for this how to be this data are to be arrived. Okay, then other situation in this and the divergent track, the siding line is coming, but here the angle of inclination is less than the angle of crossing. Okay, here 4 degree something our crossing angle means here if it is 2 degree, so the curve will be in a different way. So this connecting curve we have to introduce here. So for that how we have to fix the coordinate. Okay, this point, this overall length plus y distance. This is one type of connection situation will come. Then coming to connection, simply connection, normally when we have two lines with one cross points on crossing, if you are connecting, that's called connection. So in this case, suppose we are able to locate the points on crossing SRJ, and so where we have to, up to what distance the line should be parallel, and where we have to start the curvature, the prescribed radius, for calculating it. Okay, so how to be done. So okay, this is one type of connections. Then other type of same connections, we have one line, two parallel lines, or we want to provide some connection, introducing one point and crossing one line, providing a connection. But in the previous case, the distance is normal. Suppose for example some 60 meter, 7 meter and all. Now we can do it. But the distance is more, that is 15 meter, 20 meter means same. So when the distance is more, the center to center of track distance is more, if you are providing straight connection, it will occupy more space. That means it will affect the clear the standing room of the loop line. At the same time, it will occupy the more space, overall length. Since its overall length is more, it will occupy more space. So that is why in this case, we can provide a similar, reverse curve. We can provide a reverse curve. Instead of straight connection, we can provide one reverse curve this way. So okay, so introduce the curve. So how to get the required dimensions? Okay, this one type. So other type also same connections. If it is so far off between the two line, distance is far off. That means maybe 50 meter, 60 meter and all. We cannot go simply straight connection at the same time. One simply reverse curve also, it will take more distance. In this case, we will provide in between one straight, one reverse curve, then straight. Okay, one curve, straight, and then curve. That means the reverse curve with a straight in between. This is one type of arrangements we have. And of course crossover. So between two parallel lines we want to introduce crossover. That means we are introducing a points and crossing in both line. Okay. Connection means here the movement will be only one points and crossing through movement and turnout movement. But other loop line it is only one movement. But here in the case of crossover, both the points and crossing, it will permit movement, straight movement as well turnout movement. Okay, it's called crossover. Here we need to provide two points and crossing, both lines. So here for normal distance, we don't provide any curve in between, straight connections. When we are providing straight connections, how to be designed. In case of same crossover with large distance, slightly more, some 20 meters is there. But if we are providing a crossover straight connection, what will happen? The overall length will become more. This length will be more. So in this case also the clear standing room of the lines will be affected. That is why also the overall length is more. The area of this connection will be more. So that is why in this case we can provide a reverse curve here. Simply providing reverse curve, we can reduce the overall length. Another situation is too large, maybe some 60 meters, something like that, 50 meters, 60 meters, and in this case we can go for one straight connections in between. The reverse curve, in between the reverse curve, we can provide a straight. This is arrangement. And another arrangement, we can't say always whenever we are introducing a crossover, and the both lines will have the same point. Once sometime one line we have 1 in 8, other line we have 1 in 12. The different angle of crossing, if you want to do it, it will not be straight connection, because same angle means we can have straight connection, because different angle the extension will meet to intersecting point. So necessarily, okay, we have to introduce a connecting curve. Okay, so for doing this, how the necessary dimensions we have to calculate, we can see here. And of course symmetrical split we have seen, they normally we used to provide in a snag dead end. Okay, there we are providing the loop line 1 end of symmetrical split. Of course other line we have, suppose we have 1 in 12. Here also straight connection not possible, and because of the both lines will have some deviation, so necessarily we have to introduce a connecting curve. So this is to be designed how. And another situation, always we cannot have the parallel lines, we'll have the non-parallel lines also. So one line is going this way, other line is this way. So between that we have to introduce a crossover with the same angle of crossing or different angle of crossing. So this situation, how it is to be designed. So these are all the different type of situations we have. Okay, So all situations you have to use trigonometry and calculate the required dimensions for fixing the geometry on the field. Okay, but curve I have not put curve. We have curved lines also. Suppose two curved parallel lines, if you want to do any crossover and there won't be much difference, this normal down, this can be adopted right away. But in case of non-parallel and all, it will be a little complex. Complex means that the formula will be larger and we have to calculate. And for that, my suggestion, we can go for the graphical way of designing that one. And because once we study this one, we'll have the idea of these layout calculations. With this background, we can apply our mind and you can do necessary calculations. Data retrieval using your AutoCAD using graphical method. Okay, these are different connections. These connections in detail, worked out example we will see in the next video. In detail. So with this, let's conclude this video. I think it will be useful, and thanks for watching. Thank you.